Hi there, my name is Sharfuddin Syed. I'm a distinguished engineer at Infinera Networks. Today we are going to demonstrate a proof of concept along with CenturyLink, where we have created an innovative application where we demonstrate a cognitive application based on traffic demand based on gRPC PM telemetry data. So here is why do we need this cognitive networks and why do we need network automation? Networks are these days becoming more and more complicated, more and more unmanageable. We need a better way of defining a better network strategy where networks can be automated to give user experience. At the same time, what we need to do is basically learn the networks, detect the anomalies, detect the various PM telemetry streaming data right from the network element, understand, reason, and learn about how the network is behaving, and then take a policy-based action that can reconfigure the network elements. So that is the proof of concept. So what we are doing is providing a user experience here when the complex networks can be managed automatically. We are basically going from instructive, mundane task, which is done by operational people with a lot of hand-holding, with a lot of user touches, right from instructive to predictive to prescriptive to cognitive, which is basically means that we are building artificial intelligence and cognitive analysis in the network itself. So the way it happens is the network elements will push the telemetry streaming data, which is then detected by our intelligence piece of software. It understands, it reasons, it learns, and based on that policy that is created, it will take a proper action item to reconfigure the network element. So that is the proof of concept that we are going to demonstrate. So here is the setup. The network comprises of a XT3300 transponder network element going over the line systems. It pushes the PM telemetry streaming data all the way towards the telemetry collector. The telemetry collector in turn pushes the data to a standard-based Kafka bus. That Kafka bus can be connected to a third-party application which can be connected to smart devices which can push the notifications that are coming from the network element. That important data that is being pushed by the network element can also be used by our intelligence piece of software, which we call it AIML intelligence processor. This AIML, which is known as artificial intelligence and machine learning software, will arrive at some decision based on the learning technology, machine learning technology, and arrives at a decision which is, through the policy engine, creates the necessary action that will configure the network elements and close the loop. So that is what automation is happening here. In addition to the automation, what we have done is that all the PM telemetry data that is coming from the network directly can be pushed to a dashboard wherein the network administrator, network operator can see sitting in his living room on an iPad or on a smart device what is the network looks like. And all the policy event alerts can also come down to his smart device. One more important application is that the Presto Allegro API that is being exposed to create the policy-based engine, it's very configurable, it's very easy to use, so that the network administrator can define his own policies, and the policies can be very flexible also. Here on the right-hand side, as you can see that the gRPC PM telemetry data that is coming in is shown in very nice graphical views. Each of these graphs represents what is the real-time PM streaming data coming from the network elements. And as the EVCs are being created in this proof of concept, you can see that the policy is showing here, which is RX link utilization. If it is greater than 80%, then create another EVC. And once that EVC is created, additional EVC is created, you will see the link utilization of this link going from 100 gig to 200 gig. So the second EVC is created when the policy engine decides to create a second EVC. So that in a nutshell is the demo. Thank you very much.